All right, so let's get working on shift. Okay, so the very first thing we'll do, aside from defining it, is add in that edge case. Again, we can check if the list is empty by checking if the head is null or if it doesn't exist, or by checking if the length is 0. So I'll do length this time. We did this dot head last time. I'll do if this dot length equals 0, return undefined. All right, now the next thing we need to do is store the current head in a variable. So I'll call it old head, or shifted node, or whatever you want to call it, is right now the current head, this dot head. But that's about to change. First, we have this edge case. If the length is 1 and we remove the last item, we need to make sure the head and the tail are null. So if this dot length is equal to 1, we're going to set this dot head equal to null. I could have just copied this from above. This dot tail equals null. Okay, so that's that edge case. Now we need to update the head to be the next of the old head. So going back to this diagram, I guess I'll put it in comments because it's getting an error. If we have 99 and 100, 2 items in our list, and we have 2 connections, the dot next and the dot previous, what we want to do, we also have a reference to the head. First, this is the current head, and I've stored it in a variable. I'm moving the head to be 100. So I'm just going to say this dot head equals old head dot next. So 99 dot next, meaning this is the new head. Now we just need to sever these bonds. So it doesn't matter which one we do first. I can say this dot head, meaning the new head dot previous equals null. So that's going to remove that connection. And then I can say old head dot next equals null. This is the old head dot next is null. Old head dot next is null. And now that removes this entirely. They're not connected at all. This is called the head now, and this is old head. So I can return old head. We have one more thing, which is to decrement the length. So this dot length minus minus, and then return old head. And that should be it. So I just added in some code here, so I don't have to type push over and over, and you don't have to watch me do that. So we have our list that has 3 items, Harry, Ron, and Hermione in there. And let's do a list.shift. So it looks like that worked. We got Harry back, where next is null and previous is null. It's totally isolated. And if we look at the list now, the head is Ron. It has no previous. That's correct. It's at the beginning. And the tail is Hermione. Let's do a list.shift again. Okay, we got Ron on its own, and we look at the list. It's 1 item now, Hermione. No next, no previous. It's just head and tail are Hermione. One more shift. Aha. So we have a problem here, which is that in this scenario where length is 1, we're setting head and tail to be null. We don't want to do any of this other stuff. So I'm going to add an else here on these 3 lines and close it up there. And this is the same thing we did up here for pop. We checked if there's 1, set the head and tail to be null. Otherwise, do this. So we set the head and tail to be null because there's nothing else to do, and then we subtract 1 from length and return the old head. Let's just make sure it works. Rerun the code. So I'll do list.shift 1 time, 2 times, 3 times, 4 times. And now list is empty, but we don't get an error if I keep trying to shift like we were doing, or we were getting before. Okay, so shift is pretty much the same or very similar to writing shift for a singly linked list. We just have to pay attention to previous and next rather than only next. Next up, we're working on, surprise, surprise, unshift.